Hello students, welcome to Uncle. Good evening to all.
Evening, sir. Good evening, sir.
Good evening everyone.
Good evening, sir.
Good evening Rita. So today, first of all, we will discuss about Carnot cycle.
सर एक डाउट है
Yes.
सर यदि इंटेंसिव को डिवाइड करेंगे तो क्या होगा
किसको?
इंटेंसिव को
वो तो इंटेंसिव ही रहेगा, उसमें तो कोई फर्क नहीं.
सर कैसे रहेगा जैसे वॉल्यूम को डिवाइड करें तो एक नंबर आएगा ना
वो नंबर इज आल्सो इंडिपेंडेंट.
या सर ओके
You are already saying that it is intensive or is it extensive? Clear?
यस सर थैंक यू सर
So let me indicate it on PV diagram first, and then we will discuss about all the processes in detail. Few days back, we derived the relation between the slope of isothermal and adiabatic process. Do you remember?
यस सर
So in this particular graph, we are only having isothermal and adiabatic processes, and this is how this cycle is being completed from A to B, B to C, C to D, and D to A. Okay, and this is the first process, this is second, this is third, this is fourth. And to start with, the temperature is T1. Now, first of all, in Carnot cycle, three things are required. What are those three things? A source is required, which is at a temperature T1. Then a working substance is required, and generally this working substance is a gas, which can undergo expansion and compression. And then sink, which is at a lower temperature, and in general, T2 is less than T1. Sink is at a lower temperature than the source. Okay, you know about this one?
यस सर
Means we take heat from the source, then we do some work, and then we give some heat to the sink also, because we cannot convert 100% of the heat absorbed from the source into work. Okay, so obviously there will be some wastage. That's why the efficiency cannot be 100%. Now the first step in Carnot cycle, it is you can see volume is increasing. As you move from A to B, volume is increasing, and volume increasing means it is expansion, and because the slope is less as compared to that of BC, so it is isothermal. Okay, so step one means isothermal expansion, that is from A to B. Okay, now isothermal means the T is constant. When T is constant, internal energy is constant. Okay, and entropy TS is dq by T, na? And dq, it is positive. Why it is positive? Because heat is coming into the system. System is absorbing heat, na, from the source. So heat content of the system will increase. Means dq is positive. If dq is positive, it means the ds is positive. If ds is positive, means entropy increases. And what do you mean by entropy? What is entropy?
measure of disorder
Yes, measure of disorder or degree of randomness. Obviously, when heat enters any system, its particle, they start moving with greater velocity than in random direction. So it brings in randomness. So that's why entropy increases. So entropy increases means entropy at point B, it should be greater than entropy at point A. Isn't it? Please tell.
Yes, sir.
Clear about the first process? Now, why I'm calculating the entropy? Because later on I have to make TS diagram of this Carnot cycle also. Right now we are discussing the PV diagram. So there is another diagram which is called TS diagram. Okay, so with the help of this result, I will be able to plot TS diagram also. Now step 2. So you will tell me about the step 2. Yes, Arun, we always consider it to be the ideal gas. We never consider it to be the real gas. That's why the efficiency of the Carnot engine, it is greatest of all, because it is based on ideal concept. Now the second process, we also know that an isothermal process, it cannot accompany the second consecutive isothermal process. So if one process is isothermal, the consecutive one will be adiabatic always, and then the next one will be isothermal, like that. Okay, so it means B to C is adiabatic. Yes, and again volume is increasing, so it is adiabatic expansion. B to C. Now in adiabatic expansion, we know dq is 0, dq is TDS. So it means the ds is 0. Entropy 0 means entropy change 0 means entropy will remain same. Whatever entropy we are having at point B, same will be there at point C. Okay? Clear?
Yes, sir.
Then what is happening over here? Can anyone tell me?
Temperature is
Temperature is?
temperature of the working gas.
How can you say? This is first law. We said dq is 0. So du plus dw is 0. It means the du is minus dw. dw is positive. Why? As work is done by the system. Gas is expanding. Now, what is system over here? Gas. So gas is expanding. So work is being done. It is positive. It means the du is positive. Du is negative. And du, it is directly related to dt. Na? That is temperature falls. Temperature falls. It means Tc is less than Tb. Tc is less than Tb. This thing coming now automatically. See. Clear?
Yes, sir.
Next one is isothermal compression. When you are going from C to D, volume is decreasing. Na? So again, temperature will remain constant. Means the dt 0, so U is constant. Means UC equal to UD. And ds will be dq by T2 now. And here you can write dq by T1. Because initially the temperature is T1. And here it has become T2 at point C. And now dq is negative. Na? Because work is done on the system. Compression means we are pressing the gas. Okay? Work is being done on the system. No. In other words, you can define it with the help of dq also. In terms of dq, what we will say? That heat is leaving the system. Okay? That will be better. Because heat is leaving the system. Only then the temperature can remain constant. Huh? Therefore, dq is negative. It means the ds is negative. It means sd is less than sc. Entropy decreases. What about step 4? Adiabatic compression. D2A. Again, dq 0. This gives ds 0. Means sd equal to sa. Now, because work is done on the system. See. Please check. Now, let us try and make the TS diagram with the help of these results that we have obtained. Let us try to convert this PV diagram into TS diagram. Okay. This one understood? Clear? All the 4 steps.
Yes, sir.
Now, TS diagram of Carnot cycle. It is a rectangle. Straight question can be asked. That Carnot cycle on TS diagram, what is the shape of that? So I'm representing S along x-axis and T along y-axis. T2, T1, A, B, C, D. SA, SB, SB equal to SC, SA equal to SB, SB greater than SA. Please check. This will be the diagram. Because in first process, what is our conclusion? See, come here again. In first process, we have concluded that the entropy is increasing and the temperature is constant. So when we move from A to B, temperature does not change, entropy increases. It means it will be a straight line parallel to T axis, parallel to S axis, because temperature is constant and S is increasing. And when we move from B to C, entropy is constant and temperature is increasing. Please check everyone. Clear? Is it clear how to make TS diagram?
Yes,
If
sir.
you are given the
Yes,
PV
sir.
diagram. And one more important thing. In PV diagram, this you have already done, that the area under the curve, it represents work done. And in fact, with the help of that only, we obtain the expression for the efficiency of the Carnot engine, that is eta equal to 1 minus T2 by T1. But what is there in TS diagram? In TS diagram, yes, area under the curve represents amount of okay. Please check. Done?
Yes, sir.
Let us discuss about heat engine and try to have the formula for its efficiency. What is a heat engine? A device which converts heat energy to mechanical energy. or mechanical work, you can write. And it consists of three elements, that heat source, working substance, and sink. So here is the source, which is at a temperature T1, and there is a gas in this enclosure, and there is a sink at lower temperature T2. So this gas, it absorbs some heat from this source, let this be Q1, and then it does some work, and then it gives the rest of the heat to the sink, like this. So it means W is Q2 minus Q1. W is Q2 minus Q1. And after doing this complete cycle, obtaining the heat, doing the work, and then releasing the heat, this comes back to its original position, this working substance. Okay. Now there is a quantity which is called efficiency or thermal efficiency. So efficiency of the engine is defined as work done over heat absorbed. Simple. Okay. Means output by input. Work done is output and heat absorbed is input. So it is represented by eta. So given by work done by heat absorbed. Okay. Means W by Q. So now we can substitute for W. And Q we can write as Q1. Let me write it Q1 only.
Sir, W equal to Q1 minus Q2 होगा ना?
Yeah. मैंने गड़बड़ कर दिया. Thank you. It should be Q1 minus Q2 because Q1 is greater than Q2. So now we can substitute for W and can get the expression for eta. Now we know that Q1 over T1 equal to Q2 by T2. So T2 by T1 is Q2 by Q1. So eta becomes 1 minus P2 by T1. Okay, that is 1 minus temperature of sink, temperature of source. Clear?
Yes, sir.
Now, if heat rejected by the engine somehow, that is Q2, is equal to 0, then eta will become Q1 by Q1, that is 1. It means 100% efficiency, which is not possible. In fact, this expression gives us the maximum efficiency for any engine working between the temperatures T1 and T2. And eta is always less than 1 because we are subtracting some quantity from 1 now. Okay? Because T2 is always less than T1. So eta is less than 1. Clear? Now, let us have another formula. In this cycle, actually this 4-step process is going on through this engine. Through this engine, this 4-step process is going on. Okay?
Yes, sir.
So, expansion is going on. Here adiabatic, here also adiabatic compression. So if we define, let me tell you, if we define adiabatic expansion ratio, adiabatic expansion ratio, when adiabatic process is going on, only then we are defining it. When we are going from B to C and from D to A, you can check. Clear? Now, when we go from B to C and D to A, so when we are going from B to C, temperature is T1, at point B, volume is V2, and at point C, temperature changes to T2, and volume becomes V3. Is it okay?
Yes, sir.
So V2 by V3 power gamma minus 1 is T2 by T1. So V2 by V3, it is T2 by T1, 1 by gamma minus 1. This one. And similarly, now you can put this equal to 1 by rho. Okay. So that way we will be able to get T2 by T1 in terms of density and hence the expression for efficiency in terms of the adiabatic, not density, adiabatic expansion coefficient. So therefore, T2 by T1 power 1 by gamma minus 1, 1 by rho. So this gives T2 by T1, 1 by rho power gamma minus 1. So therefore, eta, which is 1 minus T2 by T1, it becomes 1 by 1 minus rho power gamma minus 1. You can check. Clear?
Yes, sir.
Now, one more important thing. When we obtain this formula, we said as we move from A to B, temperature remains constant. But how? How can the temperature remain constant? Can such a process be realized in practice? You are taking heat from a source or a substance and its temperature is not changing at all. Can this happen? In reality, this cannot. If we absorb some heat from something, obviously its temperature is going to fall. And similarly, if we go on delivering some heat to some object, it is going to heat up. Its temperature should increase. But we are assuming that neither the temperature of source nor the temperature of sink changes. So this is our assumption. But in practice, it will change. The temperature of source will come down a little bit and the temperature of sink will rise a little bit. Isn't it? In real life, this will happen. However small the change may be, but it will be there. It cannot strictly remain constant. So that's why we say that of all the possible engines, the Carnot will have maximum efficiency, Carnot engine. That is the reason. Because if the temperature difference between source and sink, it keeps on decreasing. Obviously, it will decrease because T1 is decreasing, T2 is increasing. The efficiency will decrease. Because we assume that they have infinite thermal capacities. Infinite thermal capacities means any amount of heat can be taken out of them and any amount of heat can be given to them without altering their temperature. And that is the reason this thing was constant. Because their temperatures were not changing. But if source and sink are not of infinite thermal capacities, that is, it becomes variable. The main thing is I want to say it becomes variable, but I've given you the explanation also that it will decrease in reality. So in such a case, in order to get the work done, what we have to do? We use integration. How? Because dW will be eta dq. We said eta is W by Q. So W will be eta into Q. So eta is this and Q is NCV dt. So it means in order to get total work done, we will integrate this expression because T2 and T1, they are variable. Okay. So this is the formula that we will be using. Otherwise, it is simple multiplication. Okay.
Sir, CPDT आएगा ना?
You can write NCP. Yes. Clear? So these things have to be taken care while solving the numerical problems. Clear?
Yes, sir.
Now, refrigerator. Refrigerator is exact reverse of the heat engine. Actually, in refrigerator, what we do? We keep on cooling the food. The temperature inside the refrigerator, it is always less than the temperature from its surroundings. Sorry. It is always less than the temperature from its surroundings. It means in refrigerator, we extract heat from a colder substance and give it to the hotter substance. Okay?
Yes, sir.
Clear, na? And of course, that cannot happen at its own. For that, some kind of machine is required because technically heat flows from a hotter body to a colder body, and we are trying to do the reverse. And that's why that compressor is required in the refrigerator. Okay?
Yes, sir.
And more we cool the food, more difficult it will be to extract the heat from the food. Okay? This is cold body. This is hot body. We are taking some heat Q2 from the cold body, and then the compressor is doing work, and then some total of them it is given to the surroundings. Heat given to the surroundings, it is greater than as compared to the heat taken from the food. Okay.
So what is done or being done on?
Work
what is done by
Actually,
the
in order to extract the heat from the food, work is being done. Na? You are extracting the heat from the food. Na?
yes, sir, yes, sir.
So sum total of them will be given as heat to the surroundings. Na? Now for the operation of the refrigerator, just as we calculated the efficiency of the heat engine, in case of refrigerator, we have a quantity which is called coefficient of performance. Okay.
Sir, what is the difference between them?
You will get to know. Actually, the process is totally reverse. Na? It is different. So earlier you wrote W by Q. Now you will be writing Q2 by W. Actually, you are trying to get the idea how well the system is performing. And how can you get that idea? How much heat it can take out from the food? Isn't it?
Yes, sir.
If it takes more heat from the food against the same work done, then obviously it is a better refrigerator. Na? It is denoted by beta. So it means beta is Q2 by W because Q2 is the heat absorbed and W is the work supplied. If Q2 is more for a particular W, then that refrigerator is better. That is a better performer. So beta is Q2 by W. And what is W? Q1 minus Q2. Na? So can I write it as this is the formula in terms of temperature. So you can see in general beta is greater than 1. As the T2 decreases, the denominator will increase. So beta will decrease. That is why when refrigerator attains very low temperature, its performance decreases. It requires more number of cycles to extract the heat from the food. I said earlier also, the more it cools the food, more difficult it will be for the refrigerator to cool it further. Because its coefficient of performance decreases with the decrease in the temperature of the food. And that's why we do defrosting. Then it gets refreshed and it again starts like a new one. Otherwise, there is no need. I'm just telling you for your knowledge. Okay? Clear?
सर defrosting means
You don't know? रेफ्रिजरेटर में आपने कभी डिफ्रोस्ट नहीं कराया रेफ्रिजरेटर में? बोलिए. वो you might have seen that sometimes there is collection of ice in the unwanted parts of the refrigerator. Na? Have you seen that?
Yes, sir.
Especially in the freezer part, the top one. Normally in which we get ice. Na?
yes sir.
There is ice all around that container. So then what we do? We switch off the refrigerator for some time and we take out all of that. Na? And then we again start the refrigerator. That is called defrosting. Okay?
Okay sir.
And it is done periodically. Normally, after 1 year or so, we have to do it. If we are operating the refrigerator at, you can say higher efficiency, there is a knob in the refrigerator na? In which they have indicated low, medium, and high.
Yes sir, yes sir.
If you are operating the refrigerator at high, then normally this stage comes earlier. But if we are operating it at low mode or medium, then this stage will come after some years. Okay. Now, why it happens? Let me tell you in detail now. Because there is ice all around that container. Na? And in order to maintain that ice or cool it further, refrigerator keeps on doing work, keeps on pushing itself, and that's why its efficiency decreases. Okay, because it is applying its energy to the unwanted thing. Na? That ice it is not needed at all. Na? वो हमारे किसी काम तो आने नहीं वाली ना. We are not going to eat that ice. Okay, clear?
Yes, sir.
So that's why it is very much necessary to remove that. I'm talking about the unwanted ice. Okay, that appears in some parts of the refrigerator. You might have seen that all around that freezer part.
हमेशा रेफ्रिजरेटर हमेशा ओपन रहे तो उसकी एफिशिएंसी कम हो जाएगी.
दोबारा बोलिए.
सर यदि हमेशा रेफ्रिजरेटर ऑन रहे तो उसकी एफिशिएंसी कम हो जाएगी.
अगर आपने defrost नहीं करा, ये कह रहा हूं. अगर if that ice has gathered and you are not defrosting your refrigerator, you will see that it will not cool down the things to that much extent that you require. वो उतना काम नहीं करेगा. But the moment you remove all of that, वो सारी ice आप remove कर देंगे, उसे defrost कर देंगे, उसके बाद जल्दी cool करेगा. I'm saying that जो काम इसको half an hour में करना है, उसके लिए it will take 2 hours if that ice is there, unwanted ice is there. Okay? But अगर आप उसको remove कर देंगे, it will cool the things as early as possible. This will be the difference. ये नहीं है कि बिल्कुल काम नहीं करेगा. It will. but it will take more time because its efficiency is less now. It is not taking that much heat from the food particle now na, for per unit work done.
Yes, पहले के बच्चे कम हो जाए.
तो यहाँ पे हमने डिस्कस करा ना, आई थिंक यहाँ पे क्या बोलते हैं, यहाँ पे मैंने लिखा भी था. I think I didn't write. I just spoke. Yes, this one. Read this one. You will get to know now. So this Q2 will decrease actually. It means in order to extract same Q2, it will take more time. That will happen when that
Yes,
unwanted ice is there.
Yes, sir. Yes, sir.
This one, Sanjeev.
No, sir. Earlier.
This.
Yes, sir. Okay, sir. Done. Go on.
Now let us try to have relation between beta and eta. T1 minus T2 होना चाहिए ना. This was ना. Yeah. Now from 1 and 2, or you can 1 minute. We can go for T1 by T2 also. No? Let this be number 1. From 1 and 2 we get. Let us take the LCM. Beta plus 1 is 1 by eta. Eta is 1 by 1 plus beta. This is the relation that we were looking for. Please check. Clear?
Yes, sir.
Now there are two kinds of processes. One is reversible and other is irreversible. And out of both, efficiency of the reversible heat engine, it is always greater than that of irreversible heat engine. Working between the same two temperatures. Two temperatures means the same temperature of source and sink. Now let me give you the proof for this. Now, first of all, you must know second law of thermodynamics. Now, what is second law of thermodynamics? Can anyone tell me? What does it tell us about entropy? Anyone? Nobody knows?
Sir, no, but now forward.
It says that entropy increases in any irreversible process. Now I think it will come to your mind. You might have read this one. For any irreversible process, entropy increases, and for a reversible process, it does not change at all. Entropy change can never be negative. Okay? So now, it means in an irreversible heat engine, entropy will increase because all the processes will be irreversible. They are irreversible. And therefore, the entropy of total system must increase over one complete cycle. Every time the engine completes one cycle, its entropy should be greater than from where it started. But the entropy of the working substance does not change. Why it does not change over one complete cycle? Because we always say that it comes back to its original position. After absorbing the heat, doing the work, and then releasing the heat, it comes back. Okay, so its entropy does not change at all. Since the entropy of the working substance does not. Note it?
Yes, sir.
Why I have written this line? Because dq is TdS, na? Heat is taken from the source. So dq is negative for the source, so its entropy is decreasing, and dq is positive for the sink, na? Because we are giving heat to the sink. So ds is positive for the sink, it is increasing. So if total entropy change should be positive, it means the entropy increase for the sink, it must be greater than the entropy decrease for the source, na? Here, let me write, because here heat is taken from the source, that is dq, and hence ds source, dq source, heat is given to the sink. So what I'm saying is that their sum total should be positive. Okay, so it means the ds sink should be greater than ds source, mode of them. Clear now? Only then the change in entropy can be positive, na?
Yes.
But in case of reversible heat engine, we have ds sink equal to ds source. Okay, reversible mein to their change will be equal, na? Only then it will come back to its original position, because total change in entropy should be 0. Clear? So let delta S is the decrease in entropy both of them working between the same two temperatures T and T dash. Let both of them extract equal amounts of heat. So now I will calculate their efficiency. Q from their source in one cycle. Let the reversible engine to the sink and the irreversible engine give Q dash I means irreversible. Now Q is T delta S, heat taken. It is for each engine, दोनों के लिए same है, because we have assumed that the heat taken is Q. Now what about Q dash R and Q dash I? According to this, delta dash S dash is greater than delta S, na? If I go by the previous conclusion on ds sink and ds source, so delta S dash should be greater than delta S, na? And now Q dash R, it will be T dash delta S, and Q dash I, it will be T dash delta S dash. Now since, because in reversible delta S dash equal to delta S, na? So both are same. And because delta S dash is greater, so Q dash I is Q dash R, greater than Q dash R. Now let eta R and eta I be their efficiencies. So whose efficiency will be greater?
Eta.
Reversible, na? Formula for the efficiency is W by Q, na? W is the difference of heat taken to the heat given by heat taken, and eta I will be Q minus Q dash I by Q. So now because Q dash I is greater, so numerator of eta I will be less, na? See? Clear? So now you can remember this result, that out of reversible and irreversible, the efficiency of the reversible will be greater always. Clear?
Yes, sir.
So let us discuss few numerical problems. This one is from IIT JAM 2006. Easy one, simple formula. The ratio of the efficiencies is given. You just have to substitute the formula. Very good, Arun. Very good, Sameshwaran. It's wrong, Divya. Very good, Kapil. Very good, Tanushri. It's wrong, Gomti. Very good, Rima. It's wrong, Uzma. It's wrong, Rishika. Very good, Siddesh. It's wrong, Gomti. Correct answer is option D. Now, let us see how. Formula for efficiency, it is given by 1 minus T cold by T hot. Temperature of the sink is always less than the temperature of source. So after solving, this becomes T hot minus T cold. Let us assume it to be delta T. And it is given that this difference is same for the two engines, A and B. Read this line. Temperature difference between hot and cold reservoirs of the two engines, it is same. So delta T is same for both the engines. Delta TA, it is equal to delta TB. It is given. So if I use this formula for the efficiency of engine A, it will give me delta TA by THA. And eta B will be delta TB. Let me write B as a superscript, because we are representing it by superscript, na? All the other quantities. So now we have to take their ratio. Na? So eta A by eta B will become this. Na? These two will get cancelled. This is given to be half. Na? But we have to get the ratio of THA to THB. Na? It will be 2 clearly. Please check. Clear?
Yes, sir.
This one is also from IIT JAM. So try to solve it. Means Q1, high temperature reservoir means source. You need to calculate Q1. If he asks you about the heat given to the cold reservoir, then it will be Q2. Very good, Arun. It's wrong, Siddesh. Rima, please check your calculation. Sumira, it's wrong. Very good, Mamta. Very good, Jashri. It's wrong, Ritika. It's very easy. Umira, check your calculations. Very good, Rita. One minute, I'm coming. There is someone. You please calculate this. I'm coming. Yes, have you solved it? Very good, Sanju. Gomti again wrong. The correct answer is actually 3000 joule. But I don't know how some students they are getting 3000 free factor. I don't know about that. See, eta is actually 1 minus T2 by T1. They are given. And if you are not sure about T2 and T1, keep this thing in mind that T2 is always less than T1. It is 1 by 3. And eta is also W by Q1. W is 1000. So I don't know how you are getting 3000 free.
I got fascinated by the word in the written bracket. 2 digits after the decimal point means there is
2 digits after the decimal point.
Yes,
but then it should be 3000.00, na?
yes, that's why I am saying that. But at first I got surprised that why.
Actually, the point is some of the students they are answering it 3000 free, but we are not getting 3000 free, na? That is a different thing. That you have to answer it up to 2 decimal point. That is okay. But how can it be 3000 free when we are getting 3000 exactly?
Yes, sir, I got.
Obviously, you will have to write this as 3000.00. Otherwise, you won't get marks. If it is written, you have to take care of this instruction, especially if they are saying up to 2 digits, then the answer is this. Okay?
Otherwise, it will get wrong.
In some of the exam, they get it wrong, especially in just exam. They get it wrong totally. Suppose they are saying you have to write the answer up to 3 decimal places, and you are writing it up to 2 decimal places, then you won't get marks in that exam particularly. But here in this particular question, they may give you marks because we are not getting any decimal point. We are getting the exact answer. But in the questions containing the decimal digits, if you forget about this instruction, then you are going to lose marks. Okay?
Okay, sir.
So this is very important. Now this one is easy question because we have discussed it today. Which one of the figures this one is also from IIT. So everybody is so quick to answer this one. Na?
This is very easy one.
Yeah. Very good. I'm getting the answers quite fast, and even I cannot see who is answering. Abe, Kapil, Humera, Ritika, Rita, Tanshri, Jayashri. Yes, Divya. Smruti Shri. Everyone is correct this time. Very good. It's B option, as we discussed in the beginning.
So very easy questions also make us surprised.
Yes. And we start thinking in the exam that how come this simple question they can ask? There must be something in this question.
Yes, so that's why I'm waiting for the all options. Otherwise, I am going to give the answer.
You have to. That is a good thing because it becomes habit. Na? The same thing you will be repeating in the exam then.
Yes, sir.
So that's all for today, students. So tomorrow again we will continue from here and we will discuss again numerous questions based on this.
Okay, sir.
Okay, bye bye. Take care.
Thank you, sir.